So, a little bit of review of graph and reciprocal functions from yesterday, right? Number one, we graphed the bottom function, which I'll call f of x first. Number two, we did all asymptotes. 3 I called nice points.
Just call it nice.
3 just should be nice. Shorten these. Ask nice. Number 4, after that, you just graph.
Gang.
That was
We are sending a message.
gang. Yeah, just use the gang method. Here we go.
That's how long. It's just how long.
Okay. So here we are going to do the graph of 1 over sine of x. So number 1, it says that would mean graph the bottom first, which nicely has been done for you.
Thank you.
Okay? And so because it's done for you, normally we graph the other function on a separate one beside, just so your graphs don't get messy and you can't tell which one's which. But since this one is done for you, we can just do it right on top. So if step 1, graphing sine of x, is done, step 2 is our asymptotes. Where do we have asymptotes? Just about everywhere. Well, almost. We have asymptotes wherever we have x-intercepts. So we have one here, 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 here. See, you think that my asymptote pen invention will be, oh, look at that. And if I could only draw straight lines, that would be good. But we'll assume those are straight. Yeah. If you're complex just enough, probably would have been better to make it straight and move it over. That is okay. Oh, not move the whole graph. There we go. There we go. Any other ones really crooked? That one. Is that one? There we go. Okay. And then underneath you can label them x equals 0, x equals pi, x equals 2 pi, x equals 3 pi, negative pi, x equals negative 2 pi, x equals negative 3 pi, x equals negative 4 pi. Perfect. Will we have a horizontal asymptote at y equals 0? No. The graph does not go up forever. It goes on forever to the right, but the highest it ever gets is 1. The lowest it ever gets is negative 1. Nice points. Can you tell me some points on the sine graph? Okay, I'll do a point right there. Where's that point? Pi over 2 comma 1, right? And that point is going to be where on the reciprocal? Pi over 2 comma 1. So I'll draw it in green as well. What's going to happen to, do this back in blue, pi over 6 comma 1/2? What's going to happen to that point? It's going to become pi over 6 comma 2. Now technically the only nice points you would need to do for this one, can you see that these are, oh, go back to green. These are all going to be at 1 and stay at 1. And these ones are all going to be at negative 1 and stay at negative 1. technically that would be enough points to show you how your graph works. I did the pi over 6 comma 1/2 so you could really see why it is that it goes up towards the asymptotes. You can also see that it can't go down towards the asymptotes because that would give you some x-intercepts, and there are no x-intercepts for a 1 over something graph. And so each of these sections here will look like this, like a bunch of little mini parabolas. They're a little bit different shape, but basically the same. And all of these ones will go down. Arrowheads on the end of your graphs, and we just graphed cosecant. I'll give you a chance to try cos. Good. So you'd have same thing as before, your asymptotes now here, 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 here. Wow, those look pretty good. That one's a little crooked. And labeling them, so now they're at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and the negative counterparts. And the shape, again, here are our nice points. And the shape is very similar to the cosecant graph. Just shifted over, which makes sense because all a cos graph is a translation of your sine graph anyways. Now something interesting or a little bit different happens with the cotangent graph. Now this one for sure would get really messy if you tried to do everything on one graph. So first of all, the graph is drawn of tan. I probably drew a few more periods than you would need to. If you were graphing it, you could probably just go from 0 to 2 pi instead of from 0 to 4 pi and negative 4 pi to 0. But if we start with our asymptotes, we have an asymptote there, there, I'll straighten these out. That one there. That one's good. Oh. Perfect. Okay. And counter to your intuition, because the tan graph goes up forever, it should be that there's an asymptote at y equals 0. Okay? There is no, this is a special case, no asymptote at y equals 0. The reason for this is you know that cotangent is 1 over tangent, and that cotangent is also what over what? Cos over sine. And there's a little bit of a difference between cos over sine and 1 over tangent. They're very similar, but there's some subtle differences. The subtle difference is, can cos be 0 here? Sine can't be 0, but could cos be 0 here? Yes. But in 1 over tan, can cos be 0 here? No, because tan is sine over cos. So that's the subtle difference. And so in the graph of cotangent, technically, you are graphing cos over sine instead of graphing 1 over tan. But when graphing, actually going to graph it, it's easier to take the tan graph and do the reciprocal than it is to graph cos over sine, because we don't know how to graph that. So if we go to our nice points, okay, on tan, that's not in the right spot. I'll move it over to this one. On tan, you know you have the point pi over 4 comma 1, right? Because tan of pi over 4 is 1. And so that's going to happen at all of these points. Tan of pi over 4 is going to be 1. And those points, when you do the reciprocal, they're not going to change. You also know in another pi over 4 family, 3 pi over 4 is negative 1. And there's a lot of other pi over 4 families that are negative 1 as well. And when you do 1 over negative 1, those values don't change. And since we're thinking of cotangent being cos over sine, when is cos 0? Cos is 0 at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So where you originally had asymptotes for tan happens to be all the places where cos is equal to 0. But in cotangent, where cos is equal to 0 is actually where cotangent is equal to 0. So wherever you had your original asymptotes on the cotangent graph, those values are all going to equal 0. With those 3 points in each of those sections, you're able to graph the cotangent graph. It goes towards the asymptotes, and it sort of looks like a backwards tangent graph.